Alright, so in this lesson we're going to talk about conditional probability, more on independent events and mutually exclusive, and then we're going to talk about probability with or without replacement. Alright, conditional probability and replacement and without replacement is probably the most confusing parts, so please pay attention to those and we'll go over that stuff in class. So conditional probability is when one event influences the second outcome. All right, and it's very important that you understand this concept because when you guys see this in a question and you guys see this notation right here, this line right here, it's very important that you understand this formula here. All right, so this is read: the probability of A happens given. So this is given. All right, given that the probability has a B already happened. All right. The formula for this is probability of A given B is equal to the probability of A intersect B divided by the probability of B. Once you guys do your Venn diagrams and we understand what the numbers are and what each term represents, it's a lot easier to find out. But the initial part is finding each and every single term. All right. Here are a couple of rules that you will have to know. If A and B are mutually exclusive, then A given B is equal to 0. The formula, using this formula up here, we can basically find any one of these values. Alright, so maybe they'll give you this value right here. They'll give you this, and they'll give you that. We can solve it for just that. Alright, they're all switchable. And then the last thing for the rules is the probability of A given B is not equal to the probability of B given A. There's two different things. I'll show you an example in just a little bit, but please note that they're different values. Alright, so here we're looking at two events, A and B, and then I give you guys this information right here. So the very first thing we need to do is find or the probability of A intersect B. And if you guys remember that A union B is the same thing as A plus the B minus A intersect B, right? A union B is 0.6, so 0.6 equals A is just 0.5 plus B, which is 0.3, and then minus, let's put X for A intersect B, right? So we have 0.6 equal to 0.8 minus X, and if we subtract 0.8, we should get negative 0.2 equals negative X, which 0.2 is the same thing as X. So this right here is actually that right there. So the probability of A intersect B is equal to 0.2. Now the reason why I needed this right here is that in order to find these two values, we need the intersection, right? All we have is the probability of A or B and A or B here, right? So we need the intersection in order to use the formula to find this. The formula again for the probability of A given B is the probability A intersect B divided by the probability of B, right? And I think it might be on the formula sheet, but just in case, try to memorize this. It's not that hard to memorize anyways, but let's fill in the numbers. So the probability of A intersect B is 0.2. The probability of B itself is 0.3. So be careful later on when you guys use Venn diagrams, because you guys are going to get confused as to what number to write, but we'll cover that later on. Alright, so 0.3 or 0.2 divided by 0.3 is the same thing as 2 over 3, and this is your answer. Alright, so now let's look at the probability of B given A. We're using the same type of numbers or same formula. The probability of B intersect A divided by, this time, the probability of A. Alright, so the probability of B intersect A is the same thing as the probability of A intersect B, so that's going to be 0.2. The probability of A is 0.5, so we're going to put 0.5. This is going to be equal to 2 over 5. So notice that this and that is not the same. All right, so please make that note. If you guys see this, these two types of questions, know that they're not going to be the same answers. All right. So we talked about mutually exclusive in the last class, and that's when two events have nothing in common. They never overlap, they never intersect, they have nothing in common. All right. When we are looking at the probability, we're going to look at two events, and we want to find the probability of two events. We use this formula if they are mutually exclusive, right? So the probability of A or B is equal to the probability of A itself plus the probability of B itself. All right. Now, what I want you also to write down is that the probability of A intersect B is going to be equal to 0. Why? Because when we draw our Venn diagram, right? And this is so ugly, but you guys understand. They don't intersect, so it's going to be 0, as in there's nothing there. All right. So let's look at a quick example, because I don't think we did many examples at last class. I don't think we did anything at all. We're picking one card from a deck of cards, right? So they have 52 cards. All right. Remember, we're going to be using decks of cards a lot. What is the probability of getting a king? All right. So the probability of getting a king, there's 4 kings, so it's going to be 4 out of 52. This is just a little introduction of just using cards, using probability with cards. The probability of choosing an ace, that's also going to be 4 out of 52, right? There's 4 different types of aces. That's going to be out of 52. What is the probability of getting a king and an ace? So that means the probability of getting a king and an ace, right? So again, we're picking one card out. There's no chance of getting a king and an ace because that's impossible, so this is going to be 0. All right, and then the last part, the probability of getting a king or an ace. All right, so the probability of getting king or an ace, that's going to be all depending on what the probability of k is, right? Because they're mutually exclusive, so 4 out of 52, plus what the probability of a is, and that's 4 out of 52. And since we're going to add these two, that's going to be 8 out of 52. And we can probably reduce that to about 2 out of 13. All right, what the? All right, my pen's getting all messed up. So it's going to be 2 out of 13. Sorry. All right. So again, the reason why we're using mutually exclusive, because we're picking one card out. There's no way of picking both of them out. So we're going to add the two probabilities together, right? We can get this. This is the probability for a king. This is the probability for an ace. Together, we're going to have a 2 out of 13 chance of getting that. So we're now going to be talking about the independence probability, right? Two events are said to be independent if the probability of B does not influence A. All right, so yeah, let me go over the example first, or the formula first. A and B are independent if and only if the intersection of A and B is equal to probability of A times the probability of B. All right, that's very important because later on they'll tell you that two events are independent. Then you're going to be using this formula to find out whatever missing variable. All right, so let's look at an example. 2 fair dice are rolled. Find the probability that 2 even numbers will show up. All right, so this is an independent probability because the outcome of one die will not affect the outcome of the second die. So as in, you roll one die, it won't affect what the second one is, right? So here, this is the first die that you roll, and this is the second die, right? The first die, you have, if you want to roll an even, you have a 3 out of 6 chance of rolling an even, right? The second die, you still have a 3 out of 6 chance of rolling an even. These do not have anything to do with each other. They are independent from each other. The probability of getting an even number for both, right? What was the question again? The probability of getting yeah, two even numbers, right, is 9 out of 36, which is the same thing as 1/4. All right, so again, if the events have nothing to do with each other, you're multiplying the two probabilities, whereas mutually exclusive, you are adding the two probabilities. All right, mutually exclusive, they have nothing to do with each other, you are adding these two. So please keep that in mind. So now we're going to talk about replacement and then without replacement. The first part is with replacement. So let's look at an example. If you take two cards from a deck of cards, what is the probability of getting two queens, two hearts, or not two of the same cards? All right, so now this whole problem will depend on whether you take that first card that you picked and you put it back into the deck of cards, and then the second card is drawn, right? So if it is replaced, then the second card will have the same probabilities as the first card. All right, so let's think about this. We have a deck of 52 cards. So keep that in mind. It's always going to be 52, no jokers. So what is the probability of getting two queens? All right, so two queens, there's 4 queens out of the whole deck out of 52, right? This is going to be your first draw. All right, so your second draw. So you say you pick the queen, you put that back, you still have 52 cards, so your second draw is going to be 4 out of 52 again. All right, so this is going to be equal to 1 out of 169 simplified, and that's going to be approximately 0.0059. All right, so you have a 1 out of 169 chance of getting two queens out of the deck, out of two events, or two picks. All right, so let's do 2 of hearts. So in this case, the first draw, you're gonna have there's 13 cards of hearts out of 52, right? You pick one, you put that back, you still have 52 cards, right? And you still have 13 hearts. So if we multiply that out and simplify, that's gonna be 1 out of 16, which is gonna be 0.0625. All right. All right. So this next one, this is the probability that not 2 of the same card occurs. All right, so to make things easier, I'm going to use the opposite, 1 minus the probability of 2 of the same cards. All right, so to break this down even more, we're going to look at the probability of 2 of the same cards, and that's so this is how it goes. Probability of 2 of the same cards, you have a 52 out of 52 chance of picking a card. Doesn't matter what card, say it's a 2. All right, you put that card back, you now have a 4 out of 52 chance of picking that exact card, all right, or exact number, let's say 2. So to simplify that, that's going to be 1 minus 1 times 4 out of 52. All right, to simplify that even more, it's 1 minus 4 out of 52. If we simplify that, that's going to be 48 out of 52. And that's 0.9231. All right, so be careful, not 2 of the same card, or yeah, same card. So say it was a 2, we have a 4 out of 52 chance of getting a 2. So this right here, this concept right here is important that you guys understand this, because there will be more questions kind of like this in our examples, right? So now this is probability without replacement. So we're looking at the same example. You take 2 cards from a deck. What is the probability of getting 2 queens, 2 hearts, and the probability of not 2 of the same card, right? So here, without replacement, the first part, you pick a card just like you already pick a card, and the probability will always be the same. However, you pick that card, you throw it away, now you have 1 less card. So instead of a 52 card deck, now you have a 51 card deck. All right, so if the card is not replaced, then the second card will have different probabilities. The denominator will always go down because you pick the card, you throw it away. The numerator might or might not change depending on what the question asks. All right, so let's look at an example. This is going to be your first pick. Your first pick, you have a 4 out of 52 chances of getting a queen, right? say you pick the queen, you throw it away, it's gone. Now you have a 3 out of 51 chance of getting a queen, right? If you multiply this out, hold on one second. If you multiply this out, you get 12 out of 2,652, which is approximately 0.0045. Alright. Hope you guys understand this concept. You have a 4 out of 52 chances of getting one queen. Say you picked one, you threw it away. Now you have a 3 out of 51 chance because you already picked a queen. There's only 3 queens left. You picked one card already, so there's one less, so it's 51. Alright. Let's look at down here. I'm sorry, this should be your second. Your first pick, we have 13 out of 52 chances of getting a card with a heart. Alright? Say you found one, you now have 12 chances out of 51 cards to get another heart. Alright? So if we simplify that, that's 156 out of 2,652. That's going to be 0.0588. Alright? The next question, same concept as the one before. Probability of not two of the same, right? Same card. So I'm going to do the opposite, 1 minus the probability of 2 of the same. And I'm going to break this down as 1 minus. And our outcome for this, 2 of the same, the first one, we're going to pick any card, so it doesn't matter. We have a 52 out of 52 chance, right? And then we will have a 3 out of 51 chance of picking that exact same card, right? So we picked a card here. Doesn't matter what card. Say again it was a 2. We throw that 2 away. There's 3 more 2s left out of 51 cards because we threw a card away, and that's our probability. If we simplify this more, we have 1 minus 3 over 51. So that equals to 48 out of 51, which is going to be 0.9412. And that's the probability of choosing not 2 of the same cards without replacement. Alright? So I'm going to stop it here today. Go back, relook at the examples. In class we'll do a couple more, a little more complex examples, but hope you guys took notes, ask questions in class if you need to, and that's it.